Hello students, welcome to the session. In this session I will be starting with a chapter called as searching. In this chapter we have two topics, one is linear search as well as binary search. So binary search and linear search we have already studied in your first semester. The same topic will be repeated in your this chapter called as searching. The only difference is here each and every method, that is linear search, will be we have a program in two methods. One is iterative method and recursive method. So we have already studied the iterative method. So the same concept we'll have our programming also. Now today we'll be discussing only recursive method of linear search, and I'll also discuss binary search using recursive method. So in this method, the first program that we are going to study today is linear search using recursive method. In this method, as you can observe here, we have two functions. One is our main function and the second one is your linear search function. All these programs are given in your notes, PDF notes, so that you can search all these. You can go for all these programs, whether it is iterative method or recursive method. Both the programs are available on the notes. Okay. Now coming for the program, we have this linear search program. So where the program is all about, we'll have an array. From the array, I need to search for an element. Okay. For that, we need to declare some variables like A, which will be taking the array elements, location, which is used for finding the location where the element has found. To identify the location, we'll be using location variable, and I, which is like, as you know, it will be identifying the indexes. Index value, if you want to access, I'll be using I, and item, which will be representing the element that we want to search. N will be representing the number of elements that we want to enter into or give the input in the array, which will be represented by N. And as you know, we have these two functions where first we will be asking the user to enter the number of elements you want, so that value will be stored into N. So and next we will be asking enter the elements. Those elements will be stored into the variable called as A, so which is a array variable. And after that, next we'll ask enter the element to search, and the element that we want to search will be stored into this variable called as item. So when I complete execution of these steps, so this will be our input. So when I complete that, we'll have, suppose if I consider the number of elements as 5 and the element that I want to search is 15, and I have 5 elements. So I have the elements as 10, 6, 11, 15 and 17. So we have 0, 1, 2, 3 and 4. So I have an array. So in the array I have 5 elements, 10, 6, 11, 15 and 17. So the number of elements is 5 and the element I want to search is 15. Now that completes this portion. Okay. So erase this. So we have taken the input of input that is required for our program. And remember, this part what I have explained, say for example, whatever we have discussed till now, that value or that statements like printf, enter the number of elements, enter the scanf followed by number of elements n, and taking the array elements and reading the element to be searched, will be common for all the 4 type of programs. That is linear search using iterative method, linear search using recursive method, binary search using iterative method, or binary search using recursive method. For all those 4 programs, what we have discussed, those input statements, that will be common. That is starting from the line where we started with enter the number of elements, from that line till the element to be enter the element to be searched followed by scanf statement, till those statements what we have, it will be common for all the 4 programs. Okay, whenever they ask any of these programs, linear search, binary search, in that case those 4 those lines of input will be common for both the type of programs. Now coming for this recursive method is nothing but, as you know, recursive function is any function calling itself. Any function calling itself will consider it as recursive function. So which will have a base condition. A base condition is where the linear search function is going to stop. which is called as base condition. And when I say function calling itself, this function call will be present in the same function itself. If you see this is the function call. That is, we are calling this function in the same function itself. Okay, so that is a recursive function. Now we have in the main function we are calling location equal to linear search of n comma a comma item. And if location equals to -1, we'll say element not found. If it is not -1, we'll say element found. And if you observe, we have already written location equals to -1 in the declaration. Okay, so that completes our main function. In the main function, we are going to read this input, and we are going to have this input one if statement, where we'll be writing if location equals to -1, we'll say element not found, else we'll say element found. So when this function is called for the first time, when this linear first search function is called for the first time, this is the function call what we have. We have linear search. First it will represent n. N is nothing but number of elements, which is 5. A, it is nothing but the array elements, or we have the 5 elements. The element that I want to search is 15. So this is the first function call that will be transferred to this sub function. When this sub function starts executing, n is less than 0, which is false. N value is what? It is 5. So it is less than 0, this will be false. If that is false, it will go to the next statement. We'll check if a of n minus 1. A of n minus 1 is nothing but n value is 5. 5 minus 1 will become 4. So a of 4, what we have the element as 17. Whether 17 is equal to item, that is the element that I want to search, which is 15. So whether it is equal to 15, this is false. If this is false, this will not be executed. That is, return statement will not be executed. We'll go to the else part and this statement will be executed. That is, we're going to call this function again. This function will be called again with different values. What are the different values? N value changed to n minus 1. That is, instead of 5, it will change to 4. And the array elements will be same. The element I want to search will be 15. That will be same. Again, once this happens, so now this function will be called again. If this function is called again, now again we are going to check whether n is greater than less than 0, that is 5 less than 0, which is false. And again we are going to check whether it is 4 less than 0, which is false. And again a of n minus 1, a of n minus 1 is nothing but a of 4 minus 1. 4 minus 1 will become a of 3. A of 3 element we have is 15. Whether it is equal to the element that I want to search, the element that I want to search is 15. So both are same. In this case, it is going to return the value as n minus 1. So this execution completes and it is going to return the value as n minus 1. N minus 1 is nothing but what? 4 minus 1, it will be 3. So that 3 will be stored into location. So we have called location equal to L search of the values. So location value now it will be what? It will be 3. So since this will return this n minus 1, so whenever you write, if you are not writing anything here, it is nothing but default will be having integer as return type. So when it returns integer value, which is 3, and that value we are going to check whether 3 is equal to minus 1, which is false. Once this is false, we are going to execute the else statement saying that element is found. This is our program to find linear search using a recursive method. Next we will continue with the binary search using a recursive method.